The recent discourse surrounding the F-35 Joint Strike Fighter has unveiled a fascinating potential trajectory for this already advanced combat aircraft, suggesting a future iteration that could incorporate capabilities pushing it well beyond its current fifth-generation status, into a realm often described as fifth-gen plus. Central to this vision, articulated by Lockheed Martin, the aircraft's manufacturer, is the prospect of a pilot-optional capability, a truly transformative step that would allow the F-35 to operate with or without a human pilot in the cockpit, adapting to diverse mission requirements and threat environments. This consideration is not merely a futuristic whim but is being actively explored as a means to ensure the F-35's continued relevance and superiority for many decades into the future, adapting to an ever-evolving global security landscape. Further augmenting this potential evolution are plans to integrate novel coatings, which would likely build upon advancements in stealth technology to further reduce the aircraft's detectability by enemy radar and infrared sensors, thereby enhancing its survivability and operational effectiveness in contested airspace. Beyond these surface treatments, more profound alterations to the F-35's fundamental airframe are also being contemplated. These significant structural changes could involve redesigning or modifying critical elements of the aircraft's chassis, a term Lockheed Martin has used, drawing an analogy to high-performance automotive engineering where a core platform is extensively modified for enhanced capabilities, sometimes referred to with evocative labels such as a Ferrari or NASCAR upgrade. Much of the technological impetus for these ambitious upgrades appears to stem from intellectual property and innovations developed during Lockheed Martin's participation in the U.S. Air Force's Next Generation Air Dominance (NGAD) program, a competition aimed at developing a sixth-generation fighter. Although Lockheed Martin's bid for the NGAD contract was ultimately unsuccessful, with Boeing's design being selected, the valuable research and development undertaken for that program are now being considered for application to the F-35. This strategic leveraging of existing, cutting-edge technology is posited as a way to achieve a substantial leap in the F-35's capabilities. However, the feasibility of successfully porting such advanced systems and design philosophies onto the existing F-35 platform is a complex undertaking, and the ambitious assertion that such an upgraded F-35 could deliver as much as 80% of the capability envisioned for a brand new sixth-generation design, but at a mere 50% of the associated cost, remains a subject of considerable scrutiny and debate within the defense community. Amidst these forward-looking, and somewhat speculative, developmental pathways, Lockheed Martin concurrently emphasizes that the current global demand for the standard F-35 models remains robust, with ongoing production and potential new international customers, possibly including nations like Saudi Arabia and India, expressing interest on the horizon. Jim Teichlet, the chief executive officer of Lockheed Martin, provided further insight into this vision during his address at Bernstein's Strategic Decisions Conference. He suggested that within a relatively short timeframe, perhaps in the span of just 2 to 3 years, the company could have a meaningful increase in capability for the F-35 specifically by migrating some of these NGAD-derived technologies. It's important to note that this timeframe, as Teichlet clarified, pertains to achieving first flight and integration of these new systems, implying initial testing and demonstration rather than full-scale production deployment. He also prudently acknowledged that any such substantial upgrades would necessitate a phased introduction into the manufacturing process, a gradual integration designed to avoid disrupting the established production flow, as attempting to incorporate too many novel hardware or software elements simultaneously could introduce unforeseen complications and delays. Delving into the specifics of the technologies under consideration, Teichlet explicitly mentioned the development and application of new infrared and radar coatings that would be applied to the aircraft's surface. The clear implication here is that the sophisticated, next-generation stealth coatings engineered as part of the NGAD program, which aimed for an even lower observable signature than current fifth-generation aircraft, could potentially be adapted and applied to the existing F-35 airframe. Such an enhancement would not only improve its low observable, or stealth, qualities, making it harder for adversaries to detect, track, and engage, but could also offer benefits in terms of maintainability, as newer coating technologies often aim for greater durability and reduced upkeep requirements. This aligns with recent observations where the U.S. military has been seen conducting secretive tests involving new, almost mirror-like coatings on various stealth aircraft, including F-35s, as well as the F-22 Raptor and even the retired F-117 Nighthawk, suggesting ongoing research into advanced signature reduction techniques. Beyond these surface enhancements, Teichlet also broached the possibility of more invasive design modifications, changes that would affect the F-35's core structure and aerodynamic profile. He explained, "There have been some adjustments or learnings, I'll say, on outer mold line, which is the actual shape of the aircraft itself, especially with regard to engine inlets and outflow nozzles that we might be able to again improve on the F-35 without redesigning it from scratch." The engine intakes and exhaust nozzles are notoriously critical areas when designing low observable aircraft, as they can be significant sources of radar reflection and infrared signature. The F-35's rear aspect radar signature, in particular, has been identified in various analyses as a relative weak spot in its otherwise advanced stealth design. Therefore, any improvements in this area, perhaps through redesigned nozzles or advanced materials, would be highly welcomed, especially as potential adversaries continue to develop more potent and sophisticated air defense systems capable of challenging even stealthy aircraft. Further expanding on the suite of potential upgrades, Teichlet added, "There's also electronic warfare improvements, networking improvements, and autonomy." Among these, he highlighted autonomy as being really critical, identifying it as the pivotal factor that could enable the F-35 to transition to a pilot-optional operational mode. Given that a considerable amount of foundational work on autonomous systems has already been accomplished, Teichlet expressed confidence that realizing a pilot-optional version of the F-35 could be achievable over a relatively modest timeframe. While the Lockheed Martin chief executive did not elaborate on the precise technical prerequisites for imbuing the F-35 with pilot-optional capability, the aircraft's inherently digitized, open architecture avionics and sophisticated communications suite would seemingly provide a strong foundation, making such an evolution technically feasible. Nevertheless, the practical benefits and strategic value of a pilot-optional F-35 configuration remain a topic of ongoing discussion, with some questioning whether the advantages would outweigh the complexities and costs involved. Particularly for a platform originally designed for manned operation, it's also pertinent to remember that the F-35 is already slated to receive substantial electronic warfare enhancements and other upgrades as part of the forthcoming Block 4 modernization package, a significant upgrade program in its own right that is currently underway, which we will return to later. Finally, concerning the infusion of NGAD technologies into the F-35, Teichlet alluded to the potential for introducing unspecified advanced weapons systems that have either been developed, or are currently in development, specifically for the sixth-generation fighter program. Integrating these new munitions would further amplify the lethality and mission flexibility of an upgraded F-35. By combining some or all of these innovative technologies, advanced coatings, refined airframe shaping, enhanced electronic warfare, superior networking, revolutionary autonomy, and next-generation weaponry, Lockheed Martin envisions the transformation of the F-35 into what Teichlet characterized as a more capable 5th-gen plus version of the Joint Strike Fighter, a platform that bridges the gap between current 5th-generation capabilities and the anticipated attributes of future 6th-generation systems. The concept of a significantly reworked F-35 is not entirely new. Teichlet had previously broached this idea back in April, shortly after Boeing was announced as the victor in the NGAD crewed fighter competition with its F-47 design. It was at that juncture that he first introduced the Ferrari or NASCAR upgrade analogies for the F-35, though he refrained from providing concrete specifics about what such an upgrade would entail at the time. He did, however, articulate a remarkably ambitious objective: to offer an aircraft possessing 80% of the capabilities of the full-fledged NGAD crewed fighter, but at only half the acquisition and operational cost. During his more recent remarks at the Bernstein Conference, Teichlet reaffirmed this 80% capability at 50% cost target, a benchmark that continues to be viewed as exceptionally ambitious, if not audacious, by many observers in the aerospace and defense sectors. "That's a set of targets that we're going after as a company," he stated, adding, "We're recommending consideration of some of those ideas to the U.S. government right now," indicating that these proposals are actively being pitched to defense officials. Conspicuously absent from Teichlet's discussion at the conference was any mention of the so-called F-55, a purported developmental version of the F-35 that then U.S. President Donald Trump had referenced while speaking to the press earlier that month. Trump had described the F-55 as a twin-engine variant of the F-35 and had also spoken of an F-22 Super, envisioned as an upgraded iteration of the F-22 Raptor. While the F-55 designation remains unconfirmed and its specifics nebulous, Teichlet did, at the Strategic Decisions Conference, suggest that an upgrade effort of similar ambition to the one described for the F-35 could indeed be applied to the F-22 Raptor. The existing F-22 fleet is already on a path to receive a number of important enhancements in the coming years, including a new infrared defensive system (IRDS), additional sensor improvements, and the integration of stealthy external drop tanks to extend its range without significantly compromising its low observable characteristics. It's noteworthy that the ongoing work to modernize the Raptors had already been contributing insights and technologies that fed into the broader NGAD program. It is also worth considering the context of Trump's F-35 remarks, which were made during a trip to the Persian Gulf region. This timing has led to speculation about whether such a concept might have been linked to emerging interest from countries in that strategically vital area. Earlier in the same month, Reuters had reported that Saudi Arabian officials had engaged in renewed discussions with their American counterparts concerning the potential acquisition of F-35s. Furthermore, both the United Arab Emirates (UAE) and Qatar have reportedly expressed desires to purchase joint strike fighters in the past. However, such sales to Gulf Arab nations have historically faced significant hurdles, primarily due to long-standing U.S. commitments to maintain Israel's so-called qualitative military edge (QME) in the region, as well as operational security concerns related to introducing such advanced technology into a complex geopolitical environment. Currently, the Israeli Air Force is the sole operator of the F-35 in the Middle East. Interestingly, in a somewhat analogous situation, both Qatar and Saudi Arabia played significant roles in collaborating with Boeing on the development of advanced versions of the F-15 Eagle, an experience and investment from which the U.S. Air Force is now directly benefiting through its acquisition of the F-15EX Eagle II. In his recent statements, Tiklat observed that in air superiority, there's a discussion about a path to fifth generation in Saudi Arabia. He elaborated, "There'll be multiple steps in that. It could take some time, but I think if we can work with Saudi Arabia, Qatar, and the UAE on really bolstering their air superiority capabilities and their integrated air and defense capabilities, there will be really significant opportunity for the company along those lines, and a few others too." While Tiklat's remarks clearly point to Saudi Arabia, it's not entirely explicit whether he implies that similar pathways for potential fifth-generation fighter sales might also be opening up for Qatar and the UAE. The phrase new air superiority capabilities and their integrated air and defense capabilities is broad and could encompass a range of systems beyond just fifth-generation fighters, including sales of advanced fourth-generation aircraft like the F-16, variants of which are already being delivered to the Royal Bahraini Air Force, as well as sophisticated ground-based air and missile defense systems that Lockheed Martin itself produces. Indeed, Lockheed Martin has already found substantial export success in the Middle East with its Terminal High Altitude Area Defense (THAAD) ballistic missile defense system and the PAC-3 series of interceptors for the Patriot surface-to-air missile system. Tiklat also touched upon the potential for F-35 sales to India, a major emerging defense market. In the same context, he raised the possibility of offering India a particularly advanced derivative of the F-16, designated the F-21. While precise details remain somewhat elusive, the Indian Air Force is understood to have experienced some attrition of its fourth-generation fighter fleet, notably during a brief but intense conflict with Pakistan earlier that month, an engagement that also served to highlight the growing presence and capabilities of Chinese fighter exports in the region. I think the F-16 also has strong legs, if you will, and more an increasing interest as we go forward from a number of countries that aren't quite ready for F-35, Tiklat commented. He further suggested that for some nations, including India, acquiring aircraft like the F-21 or advanced F-16s could be viewed as a stepping stone to F-35. To bolster this prospect, Tiklat pointed to existing industrial cooperation. "We've already started with the wing section. So, F-16 wings are co-produced in India for export to other nations." He added, "We've made commitments to literally the highest level of the Indian government, that should they choose F-21, which is the modernized version of the F-16, that we would initiate production as feasible in India for final assembly of the aircraft, as well as the wings, signaling a strong push for localized production as part of any potential deal." Returning the focus to the F-35 program in general, Tiklat also candidly addressed the ongoing challenges and issues that have beset it. Specifically, work on the aforementioned Block 4 upgrade package, and the prerequisite technology refresh 3 (TR3) improvements that the jets must receive first, continues to encounter delays. Tiklat attributed a significant portion of these delays to issues associated with an upgrade to the Distributed Aperture System (DAS), which is one of the key sensor components integrated within the Block 4 package. He explained the TR3 in detail. TR3 is a technology refreshment, a technology upgrade, from the prior F-35 core processor, which is basically the onboard server computer, a data storage unit, which is much more robust and can hold and process a lot more information, and then a pilot display generator that is the next generation, is more sophisticated, more capable. He also noted the existence of a software package, or firmware package, really, that integrates the core processor server, the data storage unit and the display generator, into the aircraft itself. He continued by providing an update on the status. The hardware is complete. It's being produced at scale at L3 Harris. The software integration with the aircraft is also complete, and so TR3 has met its completion milestones. What's going on now is that aircraft are being run through the factory with TR3, plus the first hardware component, or one of the initial hardware components, of the Block 4 upgrade to the aircraft hardware. He then identified the bottleneck. That piece of equipment is called a distributed aperture system, which is 6 apertures or antennas located around the aircraft that provide lots of sensing capabilities. The problem, he clarified, is that the holdup now is that the sensor set, a new piece of hardware and its own software and its own firmware, has to now integrate with the TR3 aircraft, and that is a little bit behind schedule. He expressed optimism, however, stating, once that catches up, we think by the end of this year, then all those aircraft that have been delivered will be combat capable with these initial Block 4 enhancements. These persistent struggles with the Block 4 and TR3 upgrades inevitably raise further questions and cast a degree of skepticism on the more radical 5th generation plus F-35 proposal. This advanced concept involves changes to the aircraft that are significantly more drastic than those currently being implemented, which are already proving challenging. The difficulties with current upgrades also make the highly ambitious 80% capability at 50% cost claims seem even more formidable. Beyond these developmental hurdles, the F-35 program continues to grapple with ongoing supply chain issues and other sustainment problems, which collectively present serious concerns about potential cost growth for both current and future operators of the aircraft. Acknowledging these realities, Teichlet emphasized, our first priority is the health of the F-35 program. What we suggested is longer-term production and sustainment agreements where we could stabilize the supply chain, get some costs down, and make sure that we can deliver on time and on schedule more reliably. Ultimately, whether a 5th generation plus variant or derivative of the F-35, incorporating such transformative features as pilot optional capability and extensive airframe modifications, will ever materialize remains to be seen. The technical, financial, and programmatic challenges are undeniably substantial. At the same time, the fact that Lockheed Martin is at least actively working towards such an end could provide the U.S. military with a valuable hedge against potential delays or other unforeseen issues in the continued development of the F-47, the Air Force's chosen NGAD successor. Furthermore, the future outlook for the U.S. Navy's F/A-XX next-generation stealth fighter program is also currently somewhat murky and less defined. In this context, the F-35 represents an existing, in-production design that offers a tangible platform that can be leveraged and evolved, potentially even if some of the more ambitious upgrades are pursued under the established F-35 nomenclature, thereby benefiting from its existing industrial base and global partnerships. As a comparative historical example, the U.S. Navy first fielded the F/A-18E F Super Hornet, an aircraft that, while sharing a designation with its predecessor, was a significantly different and larger airframe, following the cancellation of far more advanced, expensive, and entirely new aircraft designs like the A-12 Avenger II. Regardless of the final form these future developments may take, Lockheed Martin appears firmly committed to exploring the outermost limits of the F-35 design, pushing its boundaries in terms of capability, autonomy, perhaps even to the point of removing the pilot from the equation under certain circumstances, all while concurrently pursuing new and expanded export opportunities across the globe.